So I'm only going to do a few examples in class today, so that way you can have the rest of the period to be working on your assignment, okay? But again, since it's basically kind of just review for rate of change, we've already done this before, the y2 minus y1 over x2 minus x1. We're just going to be looking at rational functions today, okay? So our objective says I can find the average rate of change of a rational function. We have our concept for today. We have the average rate of change is the average change between the y values for each unit of x. And then we have a specific continuous interval for a function, okay? And so then the average rate of change corresponds to the slope of the line through the 2 points at the ends of the intervals, and this line is called the secant line, but again, that's not really relevant to Math 3. That comes more important when you get to like pre-calculus and calculus. So here's an example where the rate of change, I can see the interval -8 to -5, but the key word up here that says continuous is important because this time we have asymptotes, so it's not possible to calculate the average rate of change between an interval that crosses over the asymptotes, okay? Meaning I can't pick a point from here and a point from here because those have to cross through the asymptotes. If I were to draw a line going through those 2 points, like from here to here, for example, I cannot do that because notice it's going through the asymptotes. You can't do that, okay? So if I give you like the interval, let's say from like -6 to 0, this is not continuous. So you cannot find the average rate of change between those 2 points because they're not a continuous interval, okay? I won't ask you questions about like 2 parts. In our lesson today, we're going to see that it's going to be only from one side of the curve or the other side of the curve, but not one from each, okay? All right, then we have our steps just like we saw last time. In order to find the average rate of change over your continuous interval, and if you remember the interval, the first term is your x1 and the second term is your x2. We are going to calculate the corresponding function values for x1 and x2, meaning you're going to be calculating f of x1 and f of x2. But for simplicity, we're going to be calling them y1s and y2s instead of f of x's. So I'll do y1 and y2 instead of f of x's because I think that confuses students sometimes, okay? Just know that it means the same thing. So after you find y1 and y2, you're going to calculate the average rate of change by plugging it into the formula. I'll be sticking to the bottom one with the y's instead of the f of x's, just so that you guys don't get confused with the f of x's. All right, also you're going to have the interval in 2 different ways. We have interval notation, which is the top one. Interval notation is the one with the brackets like that. But we're also going to see inequality notation. Inequality notation is going to be like in x1 less than or equal to x less than or equal to x2. But just know it means the same thing. The x1 is basically just whatever the first value is on the interval, and x2 is whatever the second value is on the interval, okay? So we'll see it 2 ways in today's lesson: interval notation and inequality notation. All right, so let's go ahead and look at our first example. I need you guys to please put the cell phones away. You guys need to copy this down on your notes. My interval you need to copy is 5, 7. I believe you have the function. You just need to copy the interval, 5, 7. All right, so the directions up top says that we need to find the average rate of change for the interval over the specified interval. And then it says to give exact values or values rounded to 3 decimal places. None of our examples today kind of had exact values. They all kind of had to round it to 3 decimal places. All right, so to get started, again, we need to find x1 and x2 so that you know what to plug in, okay? So the first value in the interval is your first x1. Well, technically, I mean, we should be saying m's because this is an m. So it would be like m1 instead of x1, but it's the same thing. I don't care if you use x. You could say x1 and x2. And then this one would be your m2 value. So everywhere you see an m, you're going to plug in the 5 and the 7, okay? So I am going to stick to y's though. I'll just say y1. In order to find y1, you need to plug in m1 into the function. So I have 35 over m, but m is 5, so 5 minus 15, and solve for y1, okay? In the numerator, I just have 35. I can't do anything to it, so just bring it over. 35 over 5 minus 15 is going to give us what? Negative 10. And then you can grab your calculator. 35 divided by negative 10. You should get a negative answer. And you should get 3.5. Yes? Did you guys all get 3.5? Okay. So that's our y1. Then we have to go find our y2 value by plugging in m2. So y2, I'm going to do the same thing, except this time I'm going to plug in the 7 in the m. So I have 35 over m, which is 7, minus 15. That'll give me 35 over 7 minus 15 gives you what? Negative 8. And then you divide 35 divided by negative 8 in the calculator. What do you get? Thank you. Negative 4.375. Remember, guys, though, it's important where it says right here, round to 3 decimal places. Don't round until the very end. Okay. Some people tend to say that's like negative 4.4, but then because you're rounding there, your answer is going to be off at the end. Okay. So do not round until the very end. All right. So now I got my y1 value is negative 3.5, and y2 is this negative 4.375, and I got the m1 and the m2. So for my formula, I have y2 minus y1 over it's x2, but x this time we're using m, so m2 minus m1. You can say they're x's though. X's is the same thing, it's just a different variable. Okay, so the y2 we got was negative 4.375 minus a negative 3.5 all over m2, which is 7, minus m1, which is 5. okay? All right, so then you can plug that into the calculator, but when you do this, put minus parenthesis negative 3.5 close parenthesis, or you can do keep change change. So keep the first one a negative, change this positive, change this positive. So in the calculator, really you're doing negative 4.375 plus 3.5, or you could plug it in how it was originally, negative 4.375 minus parenthesis negative 3.5. And you should get negative something. What did you guys get in the calculator?
Negative
4375. Did you guys all get that? Say that again. For the numerator, just the numerator right now. Did you guys all get? Can you guys double check? Like this?
Yeah.
In the numerator? Like at the top of the fraction?
Yeah.
Okay. Haley, maybe is that your final answer?
I got the division part.
Oh, so that's the final answer. Okay. So this is negative 0.875 all over 7 minus 5 gives you 2. So Haley, was that the final answer?
Oh, yeah.
So what did you say? Negative 0.4375?
Yeah.
Can you guys all verify that? Yes? Negative 0.875 divided by 2. All right, but the directions say round to 3 decimal places. So after the decimal, you do 3 numbers. So 1, 2, 3. So I'm looking at the 5. That's 5 or more. So they add 1 more to the 7. So we're going to say the average rate of change between the interval 5, 7 is approximately negative 0.438. All right, so one more time, you look at the interval that tells you the first term and the second term. So plug each of them into the function, and that'll give you y1 and y2. And then you plug all your 4 values into the average rate of change formula. Simplify as much as possible, and then take your answer, round it to 3 decimal places. And then don't forget to write your conclusion telling me the average rate of change with the interval and then the answer. Okay? All right, so let's do this one. Notice now this time the interval is written differently. It's negative 3 less than or equal to x less than or equal to 1. And the interval is already there the function is already there for you. But this time I have it in inequality notation. So this is inequality notation. Instead of interval notation, is inequality notation. But it's the same thing as we're doing. The first term is the first one, and then the second one is your second term. Okay? So for my variable this time, it's a t. Notice my variable is a t. So then this is really a t1 and a t2. Again, you can just call them x's, x1 and x2, but just know that the t, you're going to be using the x. Okay? All right, so to find y1, we're going to plug in our t of 1, which is negative 3. So everywhere you see a t, you're going to plug in negative 3. I have 20 times t, which is negative 3, plus 3, over 4 times t, which is negative 3. And then simplify as much as possible. 20 times negative 3 would give you negative 60, plus 3 would give you negative 57, I believe. Can you guys verify? Yeah? Okay. And then 4 times negative 3 gives you negative 12. So then put that in a calculator. Negative 57 divided by negative 12. It should give you a positive value. 4.75. Okay, thank you. Okay, so now I know my y1 is 4.75. So we need to do the same thing with y2. So y2, plug in this time our t2. So t2, everywhere you see a t, you're going to plug in 1. So y of 2 is going to be 20 times 1 plus 3 over 4 times t, which is 1. So why don't you guys go ahead and try that one? Go find y2. Figure out what does the fraction end up equaling, and then the final answer.
So what's the point of the less than or equal to?
What's the what?
The point of the less than or equal to that brand.
What's the point of this?
Yeah, but for this.
What's the, it's the same thing as this. It's just written differently. So like this is, I could write this with that.
So this is
5
like the same.
less than or equal to 2 less than or equal to 7. All right, go ahead and lefties, check your answer with your partner. What did you get for y2? Yep. Yeah. Okay, so Deep Jack, can you tell me what you get for your fraction? For the fraction? 23 over 4. Okay, thank you. And then for the answer, Carlos, what did you get for y2? 23 divided by 4. Can you plug it in really quick? 5.75. Thank you. So now I know that my y2 value is 5.75. We're going to plug it all in now. So y2 minus y1 over t2 minus t1. And you can use x's too, it's fine. All right, so we're going to set it up. My y2 value is 5.75 minus the y1 value, which is 4.75, over t2, which is 1, minus t1, which is negative 3. So I want you guys to go ahead and try this one. Go figure out what the fraction is going to equal, and what do you get for your final answer. Right. So I saw 1 over 4 for the fraction. Did you guys look at 1 over 4? Yes? So if you put that in a calculator, 1 divided by 4, that gives you 0.25 for your answer. So then for your final answer, you'd say the average rate of change between negative 3 less than or equal to t less than or equal to 1 is approximately 0.25. All right, so it looks good so far. Again, this was mainly like review. You're just looking at a different function. So I think I'm going to skip the practice problem because I'd rather have you guys have time at the end to do the assignment. So I'm going to skip this one. And we're going to move on to the graphs now. So on the back page of your notes, we're looking now at graphs, and you guys need to copy the interval that's up here. On the graphs part, on the notes, you're putting the interval right here next to the graph. Versus interval, put it next to the graph. -7, -4.75. All right, so again, the first value is your x1. So x1 is -7. And then the second value is your x2. So if you remember, on a graph, you have coordinate points. And on the graph, we have the values are x, comma, y. And so I'm looking for an x value of -7. So on the coordinates, do you guys see the -7 on the x? Yes? No? We're looking for an x of -7. Do you see which of these has an x value of -7? Okay, so I see this is my -7. So that means then the one next to it is your y. So your y1 would be -0.25. And then I'm looking for the x2 value of -4.75. So which of these has an x of -4.75? Okay, good. And notice those are on the same side of the curve. So if you ever get something on one side of the curve, the other one should be on the same side. So then y2 would be 0.714. I have my values, just plug them in now. So y2 minus y1 over x2 minus x1. So I got 0.714 minus a -0.25 all over x2, which is -4.75, minus x1, which is -7. So for both of those, notice I'm subtracting a negative. So we're going to do keep, change, change. Keep, change, change. Or you can just plug it in a calculator as it shows up. Go ahead and practice using your calculator. Figure out the new fraction, and then what do you get for your final answer? All right, so let me start calling people and see what you got. Omar's not here. Alondra, can you tell me what did you get for your fraction? Over
2.25.
2.25? Did you guys all get that? Yes? All right. And then for the final answer, what did you get, Jose Gonzalez? 0.964 divided by 2.25.
$0.428.
0.428. Does it stop there? There's stuff after it?
0.428.
Okay. So it's a 4 after? All right. So to 3 decimal places, that would be your final answer. Okay. So for your answer, we say the average rate of change between the interval -7, -4.75 is approximately 0.428. All right, good. Hopefully you guys did okay on that one. Again, I'm going to skip the practice problem just because I'd rather you have time at the end of class to work on the assignment. So we're going to move on now to the tables. So I'm skipping the practice. And instead, I want to go over the tables. So on the first table, we have this and this interval here. So please copy the interval, 0 less than or equal to x, less than or equal to 2. All right, so one more time, again, in the beginning, that is your x value. So that's x1 is 0. And then the second value is our x2. And so on the table, you're looking for these x values. So on the x's, I look for 0. So my 0 is the one in the middle. So then I have this one, 0, and a negative 0.33333. And my x2, I'm looking now for 2 on here, positive 2, which is the last one. So then I have x2 is 2, and then I have that value there. Okay? So then this is x1, and this is y1. This one is x2 and y2. So for my formula, I have y2 minus y1 over x2 minus x1. You basically just plug it all in, okay? So y2, we got the negative 0.6 minus y1, which is negative 0.333, repeating all over x2, which is 2, minus x1, which is 0. So I want you to do the same thing, figure out your new fraction, and then figure out your final answer. All right, so let's check in. I know not everybody's finished yet, but for the numerator, we do keep, change, change. So the negative 0.6 plus a 0.33333, what did you guys get for the numerator? Negative what? 2 is like 6666667, right? And then 2 minus 0 is going to be 2. And if you put that, whatever you got in the calculator, divide by 2, what did you guys get for the final answer? Negative 134. Oh, because you did 267, huh? But it's basically like 1.33333333. Like, if you keep putting in the 0.3333 in the calculator, you should get negative 1.33333 with like a 5 or a 4 at the end.
Yeah.
Okay. So that's why you want to keep as many decimals as possible until the very end you round. And so because it's longer this way, we're going to do to the third decimal, which is 3. The one next to it is still a 3. So we don't round up. So our final answer would say the average rate of change between 0 less than or equal to x less than or equal to 2 is approximately negative 0.133. All right. So for the rest of the period, you guys are going to be working on the assignment. You have about, what time's the bell ring? 31? So you have about 12 minutes or so before we clean up. So hopefully you can finish the assignment. But I'm going to cut out 2 problems from it. So for your homework, what is it, 4-3? For numbers 1 through 4, you guys can just pick 2. And then you can do numbers 5 through 8. But you're doing total 6 problems. You can do all 8 problems if you want to, but I just want you to pick 2 from like numbers 1 through 4, and then you can do the 2 graphing and the 2 tables. Okay? All right.